Question number 36. Consider the following organic compounds. So we have been given 5 compounds and the examiner seems to be interested in the correct order of the acidic strength. So if you look very carefully at these species which are given to us, we can clearly see that B is going to be the most acidic out of all of them, as there is steric inhibition to resonance or the ortho effect. So B is more acidic than C and C is more acidic than A. Whereas D will be the least acidic of them all, because in this case the H donating group is OH, while in the first 4 cases it was a carboxylic acid. So we have compared B, C, A and D. Now all that is left is to compare HCOH. So these 4 can be compared as such, but this will be fact based totally. So it is a fact that benzoic acid is less acidic than formic acid. So if we talk about the correct order, we could probably have B more than C more than E, more than A more than D. So it is totally fact based. And if you look at the options which are given to us, the examiner seems to be interested in the incorrect order. So if you look at the first option, which says that B is more acidic than C, is more acidic than D, this is correct, students. If you talk about the second option, which says that C is more acidic than A, is more acidic than D, this is also correct, students. If you talk about the third option, B is more acidic than C and C is more acidic than A, this is also correct, students. So the fourth statement has to be automatically incorrect. If you look at the option, you can clearly see that E is more acidic than A and this is incorrectly given. So students, for this question, we have to select the incorrect statement and we have to mark the fourth option. Let us look at the next question. Question number 37. In the following reaction sequence, so we have been given the substrate which is allowed to undergo a series of reactions and ultimately leading to the formation of product B. And the examiner seems to be interested in the functional group which are present in the compound B. So let's try and solve this question. So in the first step, we have O3 present with DMS, which is dimethyl sulfide. So it is reductive ozonolysis. Reductive ozonolysis will convert this structure. It will break the double bonds and convert this into corresponding carbonyl compounds. So we're going to have the formation of this structure. This is the product A which is formed. Now this A is allowed to react with the Tollens reagent. So this Tollens reagent will oxidize this aldehyde into acid, but it will not affect the ketone group. So on reaction with Tollens reagent, it is going to convert this structure A which was formed into this structure. So if you talk about the major compound B which is formed, it contains a ketone and it contains a carboxylic acid group. So if we talk about the options which are given to us, we can clearly see that we have to mark the third option as the correct answer. Let us look at the next question. Question number 38. In the given reaction sequence, so we have this reagent allowed to react with 2 moles of PHLi. If we talk about PHLi, students, the PHLi contains pH minus ions. So the given substrate is to be reacted with 2 mole of pH minus. So the first mole will extract this acidic hydrogen which is present and the second pH will attack this carbonyl carbon. So we're going to have the formation of this structure, and when this is allowed to undergo hydrolysis, leading to the formation of this structure. This is the structure A which is formed. Now this is allowed to react with CH3CO3H, which is the peroxyacetic acid, and the examiner seems to be interested in the Baeyer-Villiger oxidation. So it is given to us that in the Baeyer-Villiger oxidation, the migrating tendency of phenyl is more than cyclohexyl. Students, in this case, we are going to have the formation of this structure. So if you look at the options which are given to us, students, we can clearly see that we have to select the second option as the correct answer. Let us look at the next question. Question number 39. In the given reaction sequence, so we have the given substrate undergoing reductive ozonolysis followed by the aldol conditions. So if we try and figure out the compound A which is formed, so the reductive ozonolysis is going to break this double bond and convert it into corresponding carbonyl compounds. So we're going to have the formation of this structure. So this is the product A which is formed. If we talk about the next reaction, which is the OH minus in presence of heat. So this is the aldol conditions, and the aldol conditions will first lead to the formation of a carbanion. at the alpha position, and that will make an intramolecular attack at the other carbonyl group which is present, leading to the formation of a 5-membered ring adjacent to the benzene ring with a hydroxy group present at the beta position. So upon heating, this will undergo loss of a water molecule to form alpha beta unsaturated carbonyl compound. So this is the compound B which is formed at the end of the above reaction sequence. The examiner seems to be interested in the index of hydrogen deficiency, which is also the degree of unsaturation, or DU in short. So if we talk about the DU of this compound, we're going to have a total DU of 7. So if you look at the options which are given to us, we can clearly see that we have to mark the fourth option as the correct answer to this question. Let us look at the next question. Question number 40. In the following given structures, which carboxylic acid will not undergo decarboxylation on heating? So if we talk about the carboxylic acids which undergo decarboxylation upon heating, we have to have a electron withdrawing group present at the beta position. Or we can have a geminal diacid. So geminal diacid contains both the carboxylic acid groups at the same carbon. So if you talk about the first condition, which is the presence of an electron withdrawing group at beta position, we can have beta keto acids. So if you look at option 1 is a beta keto acid. This is correct, students. If you look at option 2, it is both. It is a beta keto acid as well as a geminal diacid. So this will also undergo decarboxylation upon heating. If you talk about the third option is also a beta keto acid. If you talk about the fourth option is also a beta keto acid, but the carbanion will not be generated at the Brigitte position. So this will resist decarboxylation upon heating, and we have to select the fourth structure as the correct answer to this question, and we have to mark the option 4 as correct. Let us look at the next question.